Namaste. Welcome to the video lecture series on the chapter Periodic Table of an Element. In this video, that is video number 7, we are going to discuss about what are groups. What are groups? Although we have taken a basic important part about what are groups, now here we are going to discuss slightly in detail about the various groups present in modern periodic table. So the groups are basically vertical column present in modern periodic table. Groups are vertical column present in a modern periodic table that we know as a group. Now there are total 18 vertical column. So we have some 18 groups are present in modern periodic table. 18 groups are present in modern periodic table. Now every vertical column or every group is been assigned with some number. Every vertical column or the group is been assigned with a number which we known as the group number of that group, which is known as group number of that group. So generally this group number is based on the number of electrons present in the outermost shell of that atom in a particular group. It is basically the number of electron which is present in the outermost shell of that atom of an element present in that group. So let me take a few examples to illustrate this. Hydrogen. Let me have hydrogen. Now it has got atomic number 1, electronic configuration 1. So the group number of a hydrogen is 1. Then I have calcium, atomic number 20. So the electronic configuration becomes 2882. Now as we can see, in the outermost shell of calcium has got 2 electrons. So its group number is second, which is represented by another notation, second A. This can be taken as first A. The A indicates the normal metals or representative elements. The normal elements or representative elements, we can have it. Now let me have aluminium, whose atomic number is 13. So the electronic configuration becomes 2, 8, 3. Now as aluminium has got 3 electron in its outermost shell, so its group number will become 3A, or it's also written as 13th. Now why 13th? Because in between 3 to 12 I have some 10 transition elements. These transition elements we don't have in our study. So I have to add in that valence shell 10 electrons there. So 3 plus 10, that becomes total 13, hence the group number becomes 13th. Or you can take another element, like let me take chlorine, whose atomic number is 17. So electronic configuration becomes 287. Now as you can see here, there are 7 electrons. So this 7 I convert into Roman number, that is 7A, or as there is a 10 transition elements are present, so I can write down here 7 plus 10, that is 17 group. So this is a group number. Now generally every element, whatever the number of electrons present in the outermost shell, that has been represented by its group number, group number. So there are 2 notations we normally use. One, the old system, and the second we call it as a new system. The old system and the new system. Now in the old system we have, this is given as first A, second A. Now this is your transition element. These are your transition elements. Okay. Now then I have here directly third A, fourth A, fifth A, sixth A, seventh A, and this is a 0 group. This is a 0 group. Now in between here I'll be having third B, fourth B, fifth B, sixth B, seventh B, and there are three vertical columns of eighth. Eighth is not been divided into any subgroup. Then I have first B and second B. So basically we have total 18 vertical lines. So let me show how 18 vertical lines have been divided. So 18 groups. Now those have been given Roman number. First A to 7th A, that is 7 vertical line. Okay. Then first B to 7th B, under the 7 vertical line. 8th is not divided into any subgroup, but it has got 3 vertical lines. And then I have 0 group. It has got 1 vertical line. So that becomes total 7 plus 7, 14. 14 plus 4, 18. Now, this AB notation is an old system. But with the IUPAC coming into picture, the AB notation has been removed and all the groups have been given continuous number from 1 to 18. All the groups have been given continuous number from 1 to 18. So let me have an old notation, that is 1A. Then I'm having here that is given as a first group. Then I have second A, that's been given second group. Then here I have third B. There I have third B, that's a transition element starts. Third B becomes your third. Fourth B becomes fourth. Fifth B becomes fifth. Sixth B becomes sixth. 7B, that becomes 7th. Now as you can see, your 8th group has got 3 vertical columns, first, second, third. So it has got 3 vertical columns. So this is your 8th first vertical column, that has been given 8th group. Once again 8 second vertical column, that's been given 9th group, and one more vertical column, that's the third 8th vertical column. The third column, third, we have that 8th group one. So it has got, that's been given as a 10th group. Then I have next one is the first B. Next is first B, that's been given 11th, and second B have been given as 12th. So these are how your transition elements have been named from third B to second B, that is all the B group element which starts from third group to the 12th group. Now once again I come across A series, that is your third A. So it will be now 13 group. Fourth A will be 14 group. Fifth A will be 15 group. Sixth A, that will be 16 group. 7A, that is your 17 group. And next I have 0 group, that's been given 18. That will be given as 18 group. So this is how the notation works out in terms of first A, second A. So I'm just writing those again here. So this is the first group, this is second group, this is third group, fourth group, fifth, sixth, seventh, 8th, 9th, 10th, this is 11th and 12th. Then I start here with 13, 14, 15, 16, 17 and 18 group. So this is how the groups have been given number, the old system and the new system, the old system and the new system. Now next we have some indication about which groups have been known as what, that we try to look out. Now let me discuss certain points here about which groups have been known by which name. So I have The element which are belonging to subgroup A, they are called as normal elements, or it's also called as representative elements. Now, the most specialty about this element is that they have their outermost shell incompletely filled. They have got their outermost shell incompletely filled. You can take an example in terms of sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. All these elements, we call it as a normal element or representative elements because they have their outermost shell incompletely filled. They have their outermost shell incompletely filled. Now, the elements which belong to subgroup B, the element which belong to subgroup B, that is from the group number 3rd to the group number 12, they are called as transition element. They are called as transition elements. Now these elements have got their two shell. They have got two shells incompletely filled. That means outermost two shells are incompletely filled. Now, if you carefully observe the periodic table, I have some elements have been placed at the bottom of periodic table into two separate series. To carefully observe here, I have two series of elements. They have been placed at a separate series, which we call it as an lanthanide series, and the another is actinide series. Now, these are the group of 14 elements which do not find place in main framework of periodic table. These are the group of 14 elements which do not find place in main framework of periodic table. They are placed at the bottom in a two separate series, that's called as your lanthanide and actinide series. Now they are generally called as inner transition element. They are generally called as inner transition elements. Okay. Now here we have already discussed, as the number of electrons present in a valence shell of an element is same, like if you talk about a group, then because of this particular, the element present in a particular group will have same chemical property as the number of electron present in the outermost shell of an element in a particular group, that remains same. Due to this, the chemical property of those particular element also remains the same. So each element in a group will have same number of electron in valence shell. Because of this, their chemical properties are also found to be same. The chemical properties are also found to be same. Now, we have some specific names given. In a previous video also we did discuss about these things. Group first or first A element, we call it as an alkali metal. Group second or second A element, we call it as an alkaline earth metal. Group 17 or 7A elements, we call it as an halogen. We call it as an halogen. 18th or zero group element, we call it as an inert gases or noble gases. Then the element from 3rd to 12th or 1st B to 7th B inclusive of 8th group will form a transition element, So this is a small introduction about what are groups and what these groups have been known by some specific names. Thank you for watching.